All right, now we are ready to be talking about the derivatives of the inverse trigonometric functions. To develop these formulas, we're going to need a process called implicit differentiation, which we haven't quite studied yet. It's in an upcoming section. So we'll be able to come back and see how these formulas were developed after we obtain that tool. Right now, we're just going to accept these formulas and go ahead and try and use them. Let's look at some examples. I want to take the derivative of 9 times inverse sine of x. That 9 is a constant, so it's just going to stay there. The inverse sine of x, we're using this formula right here, so that's 1 over the square root of 1 minus x squared is the derivative. So cleaning that up a little bit, we're going to have 9 over the square root of 1 minus x squared. Now for this next example, we're doing x times inverse cosine of x. And notice I said a times there, so this is a product rule. So in taking this derivative, we're going to leave the x alone and take the derivative of inverse cosine of x. Now that's this formula right here. So notice that looks exactly like the one for inverse sine, except it's got a minus sign on it. And then plus, now we're going to take the derivative of the x, which is a 1, and leave the inverse cosine of x alone. All right, so cleaning this up a little bit, we're going to have a negative x over the square root of 1 minus x squared plus inverse cosine of x, and that's what our derivative is going to look like there. Now with this next one, h of x, again I have 3 to the power of x times inverse cosine of x. Again, this is a product rule. But with the 3 to the x, remember this is our exponential, so we're using the formula that we learned in a previous section that the derivative of a to the x is a to the x times the ln of a. Here my a is a 3. So for h prime, I'm going to differentiate the 3 to the x, and using this formula right here, it's going to differentiate to 3 to the x, ln of 3, leave the inverse cosine of x alone. Now I'm going to use some parentheses here to make sure it doesn't look like the functions are combined in some way other than just a multiplication. All right, so we differentiated the 3 to the x and left the cosine alone. Now part of keeping going with the product rule, we're going to do plus, leave the 3 to the x alone and differentiate inverse cosine. That's this formula right here. So negative 1 over square root of 1 minus x squared. All right, now when we go to clean this up, notice that there is a 3 to the x in common. So I'll factor that out front. From this first term, I have ln of 3 times inverse cosine of x. And then when I factor out the 3 to the x here, I'm just going to be left with a minus 1 over the square root of 1 minus x squared. So that's what our derivative looks like there. Now, let's take our derivative here. So notice that that 3x to the 5th is just 3x to the 5th. Its derivative is 15x to the 4th. No problem. But again, here we have 5x times, so this is once again a product rule. So differentiating the x, it becomes a 1, leave cosecant inverse alone. And then plus, but we've got the negative there, right? So plus a negative 5x is left alone. And then the inverse cosecant of x, we're using this formula right here. So negative 1 over x square root x squared minus 1. All right, cleaning this up a little bit, we're going to have 15x to the 4th minus 5 inverse cosecant of x minus, and minus, we'll make that a plus, 5 x and x will cancel because one is in the top and one is in the bottom. Let's go back to that. And so when those x's cancel, we're just going to have over square root of x squared minus 1. So this is what our complete derivative here will look like. All right, let's move to that next example now. So here I'm looking at inverse tangent of x divided by x squared plus 1 divided by means we are doing a quotient rule. So leave the bottom alone, x squared plus 1. Derivative of the top. For the derivative of the top, I'm using this formula right here. So 1 over 1 plus x squared. Minus, now we're going to leave the top alone, inverse tangent of x. Derivative of the bottom, the derivative of x squared plus 1 would be 2x plus 0, right? Over x squared plus 1 squared. Now notice x squared plus 1 over 1 plus x squared, that's the exact same thing in the top and the bottom. Those items will cancel right here, and I'll be left with, let's go back, sorry. And I'll be left with just a 1 in that term. So 1 minus, I'm going to bring the 2x out front as a coefficient so it's clear, 2x inverse tangent of x over x squared plus 1 squared. So this is what our y prime looks like for this function.